Okay, so looking at some examples of a reduction formula. The first one I want to look at in particular because this square just seems to make some of you crazy. And by crazy, I mean wrong, like you get the wrong answer. Okay, so what I want you to do, anytime you see a square in trig, especially when you have to use a reduction formula, I want you to take it to the outside. So basically, make square brackets, right? What would be on the inside usually, so cos 180 plus theta, and then squared. And I'm going to show you why I want you to place that there. Because now when we do reduction formula, you'll see something happen. Remember, we always check sign, then we check ratio. Okay, keep it in that order and you'll always get it right, I promise. So 180 plus, we ask ourselves, is cos positive or negative in that quadrant? 180 plus will put us into tan's quadrant. So we know cos is going to be negative. Then we check my ratio, 180. Does it change or stay the same? Only changes for 90, so it stays the same. Negative cos theta squared. Don't forget about it. So do you see now that this whole ratio is negative, but it's squared? And we know when I square negative, it basically becomes positive. Because this is technically negative cos theta times negative cos theta. But you can miss this step, you don't need to include it. So we know then my final answer is actually positive cos squared theta. So the mistake some of you make is that you carry down the squared and then you'll write it as negative cos squared theta, which is not obviously correct. So just a tip, when you have a square, move it to the outside. I promise it'll make life so much easier for you. Right, so that's the first example. Second example, did a bit of a numerical one just to keep things interesting. So we have tan 150. Right, so 150 we know will be obviously between 90 and 180. So somewhere over there, right? 150. So we see we actually have two options for this. Either we can say that that is tan 90 plus something, or we know it can be tan 180 minus something. Right, really up to you. Both will give you the same answer. But remember that with the 90, we're going to have to change to the co-ratio. So with tan in particular, I don't like changing to its co-ratio, so then I would usually opt for the 180. I will do the 91 as well, just to illustrate what it will be and how it will still get to the same answer. But for now, I'm going to do the tan 180. So 180 minus what gives me 150? That'll be 30. And if you've got a keen eye, you'll notice that is a special angle. So I'll say 180 minus, which quadrant is that in? Obviously, the second quadrant. So we know that it is negative. 180 stays the same. Negative tan 30. So from my special angle triangle, I know if that is 30, that is root 3, 1, and 2. Tan is opposite over adjacent, so my opposite is 1 over my adjacent, root 3. Final answer being negative. What did I say? Opposite over adjacent. Negative 1 over root 3. So that over there would then be your answer. Okay, I'm going to do it now with the 90 plus just to show you it gets to the same answer. Hopefully it does. If it doesn't, I'll just probably edit it out. Okay, so 90 plus what gives me 150? 90 plus 60. Again, we see special angle. So now we will reduce. We say first, I'll check my sign. So 90 plus, still in the second quadrant. So still going to be negative. 90 changes to its co-ratio. So tan is the only ratio that's co-ratio and reciprocal are the same. So its co-ratio will be cot. And then obviously just 60. So I'll obviously now be using the same triangle just with the 60 being of importance. 1, root 3, and 2. Cot is the inverse, well, it's the flipped fraction of tan. So instead of being opposite over adjacent, it is adjacent over opposite. So 60 is 1 over opposite root 3. Same answer. All right. So it really doesn't matter. It's really up to preference. Okay, cool. So for our last example, let's look at right, let's look at 660. So let us say sine of 660. So this also usually throws some of you because like I said with reduction you're used to 90, 180 or 360 plus and minus. But obviously 660 now lies outside of my 360, outside of that full revolution. So you need to keep in mind, right, that whenever you have an angle that is above 360, which is a full revolution, you minus 360 from that until you get an angle that is below 360. So we will actually be minusing full revolutions from that until we get to an angle that is below it, right? Okay, so if you think about it, basically what we're doing is that 60 would have been a full revolution and then some. Are you with me? So if we minus a full circle, we're taking that first part away and we'll still end up in the same position, right? Again, because of the way that my graphs repeat itself, I can minus that full wavelength from it. Okay, eraser. So with 660, I'm going to minus 360 from it, and it will still be the same ratio. So minus 360 from 660, minus 360 from 660 will leave me with sine 300. Right, and now I see that my 300 is between 0 and 360. So I can actually apply a reduction formula to it now. So I will say, or let's make it squared just for interestingness. Yeah, right. So first thing I'll do with my squared, what I'm going to do, take it to the outside. So I'll say sine 300 squared, right? Because we know squared will move to the outside. Next, I need to write this in terms of reduction. So it will either be 360 minus, or, well, it will just be 360 minus because we don't do 270 anymore. So I will say that that is 360 minus what gives me 360. Notice, special angle, right? Just quickly with this again, some of you get confused. Remember that whatever is in this bracket in terms of the sum needs to equal what is there. So like some of you might say 300 minus 60. And I know what you mean. You mean that obviously you would minus 60 to get that. But make sure that what is in this bracket equals that bracket. Okay. Next, I will now do my reduction. So first check sine, then check ratio. Moving to my cast diagram, 360 minus will place me in the fourth quadrant. So we know that cos is only positive there. So sine is negative. 360 or 180, my ratio stays the same. So that'll just be negative sine 60. First, I'm going to change it according to my special triangles. So special triangles, we know that's 60, that's 1, root 3, and 2. Sine is going to be opposite over hypotenuse. So that will be negative root 3 over 2 squared. With squared, we know we can distribute it in. Firstly, the negative will become a positive. Root 3 squared is just 3. 2 squared is 4. Final answer, 3 over 4. Right, okay. Thank you for watching. That's us. Thank you for watching.